name is Tesla stock price prediction. Project summary. This project successfully built an end-to-end deep learning forecasting pipeline to predict Tesla stock price trend using historical time series data. After handling market anomalies via quantitative capping and stabilizing exponential variance with long transformation, we engineered sequential time lag features and rolling momentum indicators to capture temporal dependencies. We then implemented and compared three sequential neural network architecture, SimpleRNN, RNN, LSTM, GRU. While the baseline SimpleRNN struggled with gradient limitation, the gated model effectively rented long-term market context. The train-gated recurrent unit was selected as the final model due to its superior computational efficiency, lower error metrics like MAE and RMSE, and strong trend explain power. Finally, the optimized production model and scaling assets were serialized directly to Google Drive. Deliver delivering a reliable automated framework for volatile market risk assessment and algorithmic decision making. Problem statement. Now start code part. First, import libraries like NumPy, Pandas, Matplotlib, Seaborn, TensorFlow, Scikit-learn. Then, first 5 view. How many rows and columns? Here row is 2416 and column is 7. Duplicate value not present. Then missing value also 0. Then understanding your variable. Here see 7 types of variable like date, open, high, low, close, edges, close, and volume. Then check unique value. Data wrangling for date. Now data visualization. Here I can separate 3 types of charts. First is univariety, second is brevity, and third is multivariety. So first we see univariety charts. Line chart of Tesla adjust closing price over time. Here I can choose line chart. Second one, distribution plot of adjusted closing price. Here I can choose histogram. Box plot of adjusted closing price. Box plot. Distribution plot of training volume. Here I can choose histogram. Then box plot of trading volume. Now second one is brevity charts. Scatter plot of trading volume vs adjusted closing price. Then daily price range vs trading volume. Here I can choose scatter plot. Then average adjusted closing price by year. Here bar chart. Box plot of closing price across month. See here. January to December. Now open price vs closing price. Scatter plot. Now last multi-variety charts. overlaying open, high, low, and close price over time. Multi-line charts choose. Candle axis chart. Moving average trend chart. Multivariate. Correlation heat map. Last, pair flow. Now new section, hypothesis testing. See here, I can test 3 types. Statement 1, 2, and 3. Feature engineering and data preprocessing. First, we can handle missing values. See here, missing values for column before treatment and after treatment. Here we can see some missing values present, then we can remove, like handle. Then handling outliers. Categorical encoding. Textual data reprocessing. Here we can see our data set in CSV file not present textual data, so we cannot put any code here. Feature manipulation and selection. First, manipulation, then selection. Data transformation, then scaling. Dimensionality reduction. Dimensionality reduction is not needed here. Data splitting, handling imbalanced data set, also not needed. Then most important part is ML model implementation. First, I choose model 1, which is simple RNN baseline. First model, right. Second one is LSTM, a long short-term memory. Second one, and third one is GRU, gated recurrent unit. These 3 models train for our more better output. Then feature works, dot pickle file save, and last sanitary check. Now conclusion. Data insight analysis of the Tesla dataset proved that trading volume alone does not determine price direction. However, applying rolling time lags and log transformation effectively stabilized and stocks high volatile patterns. Model performance. While baseline simple RNN models struggled with memory limitation, sequential gating models, handling long short-term trend smoothly. Final selection model 3, uh, like GRU, was selected as the final production deployment model. It achieved the best balance of predictive accuracy while utilized a more efficient, faster training architecture. Baseline impact, this pipeline gives financial teams a reliable tool to forecast directional trend safely, automated algorithmic execution, and manage capital risk during volatile market phase. Now we can see lab out. See here simple uh, page. I can deploy with Streamlight. See first day one old data set, then day two intermediate, and day three most recent. I can three types of choose old one, intermediate, and most recent, like past, present, and future. Future. See successfully output show row output scaled prediction. Here I can put charts, then GRU architecture detail also put, and last one is engineer feature metrics. All details are put below. So this is my lab application. So thank you.